Now it is visible, right? Okay. Now it is visible, right?
Yes, sir.
Is it okay? Shall we proceed?
Yes, sir. You can proceed.
So last class we have seen something about the capillarity rise and all. Okay, capillarity rise and surface tension and so on. There was one more topic also, suction, but may not be important in undergraduate level. Okay, if you are interested, you can go through it. Suction is because of that capillarity only. Today we'll focus on the next chapter. Okay, so seventh chapter was very small, and we'll focus on the permeability. This is very important actually. So this permeability test we'll do in our laboratory also, or even field also we'll do permeability. So I think here they have written mistake here wrong. Okay, PER permeability, PER permeability. Okay, so people write book, no, they will write very well inside the book everything is fine, but look at the title. Okay, they have done mistakes here. Okay, so it is permeability, PERM, permeability. Okay, so this will be new term for you. Okay, the permeability means uh, porous material, or you can say it is a property of a soil, okay, which permits the flow of water, water or liquid, okay, through it. So it is a property of a soil, okay. So permeability. So it will allow water passes through. Anyway, we know that water will flow through the soil, okay. So the permeability, the word is the ease with which water can flow. So if it is easily flowing through it, then we say that water flowing very easily, then we say that soil is not permeable, permeable or impermeable. We call it as impermeability. So which soil will in which soil your permeability will be more? If I ask you, which soil? Which soil allow more water, water to flow? Okay,
Clay
which,
soil.
that is
Gravel.
wrong. Okay, gravel and sandy soil will be more permeable. Okay, here it's not capillarity. Okay, here, so more voids means more water will flow through it. Okay, capillarity is a small tube. Okay, if the tube size is increasing, there won't be any capillarity. Okay, so again that depends on the small voids. Okay, that's the reason we have discussed that one. Here, water flow we are talking about. Water would be flowed. It is the property of a soil which permits flow of the water. Okay, through it. It is called the permeability, or the permeability is the ease with which water can flow through it. Okay, a soil is highly pervious when the water can flow through it easily. Okay, uh, for impervious soil, it is a very low water. Water cannot easily flow through it. Okay, so we have this clay type of soil are more impermeable. Okay, so that's the reason. If you see the clay dams, okay, the earthen dams and all, or if you are if you belongs to farmers background, okay, if your grandfather or father, somebody is a farmer, they you might have seen, right, they divide the field and they will use the clay to arrest the water, okay, seepage of the water. They don't use in the cement and all, they use clay, because clay is more impermeable. Okay, it will not allow water. If you make a clay liner or a clay, okay, it will stop the water of seepage, because clay is more impermeable. Okay, that's why we use some china clay we'll use, or we use bentonite clay for arresting the water, the stopping the seepage of water. Okay, So this clay type of soil is more impermeable, but sandy soil, easily the water can flow in sandy soil, okay. Sandy, gravelly, because it is more porous, and thing voids are also bigger compared to the clay soil. In the clay soil, voids are more, okay, but smaller size, okay. And clay soil will have electric charges along the surface also, that will absorb water through that one, and it will try to hold the water, it will not allow water to passes, okay. But sandy soil, gravelly, it's like it won't interact much with the water, it's the inert material, okay. So water passes very easily. That's why you could see in the beach, if you dig a small pit, okay, water easily come into it, okay. So that's, and then people where easily will come out, just away from your sea, little away, and just dig a pit. So since it is a pervious, or you can say permeability of the sand is very high, so easily water will come flow into it, okay. So so that's the logic behind this particular chapter, okay, permeability. This permeability is very, very important for our, and it is an engineering property, it's not an index property. Index properties are liquid limit, plastic limit, shrinkage limit, okay, and will class plasticity index, liquidity index. So these are the indexes we use for classifying the soil. Just we have classified it. Okay, this is a sand, clay, sandy clay, and dual symbol, and so on. But permeability, the engineering properties, because if the soil is more permeable, we have to plan our construction, right? So the settlement depends on the permeability of the buildings where we are going to construct, okay, and the swelling characteristics, CPS, or when you want to construct a dam. So permeability of the soil is very, very important. Okay, first we'll classify soil, what type of soil it is, how the permeabilities are going to be in future. Okay, because water will really affect our construction. Okay, we don't like water. Okay, in our construction, water is good for irrigation and all, but when it comes to the construction and the soil, that disturbs everything, right? Because when you saturate the clay, which is more stiff, become very soft, is it not? So it damages strength. So wherever water is not there, there we have to construct a foundations. Okay, there we have to. If it is in waterlogging area, what happens? Soil will be very soft and it may settles. Okay, or that's why it happening in our all cities. Okay, and even all villages, even our Trichy itself, it is located on the bank of a river. Okay, this particular city. Okay, Kaveri River, you just see from NIT to Katur or Trichy, you see a road is on an elevated place, but all our buildings left and right side you just see. So when I have joined in NIT, it was fully irrigated land, okay, from the BHL to there. Now you could see some buildings, so fully irrigated land and paddy field, and so many things were there, okay. So nowadays they have started constructing building in it, and it is costly also nowadays over there. So what is happening is uh, because it's not in elevated place again, there may be chances of flood, there may be chances of waterlogging, because it is a fully clayish type of soil, okay. And even the clay type of soil means if you try to hold the water, when water is held by the clay, what happens, there may be swell and the shrinkage. Because of this swell and shrinkage, what will happen, this will try to lift our foundations and settles down, and that disturbs our whole structure. Slowly you could see some cracks in the buildings and so on, okay. Or if at all any rain comes, right, so what happens, everything, the water comes to in our house, okay, and so on. So our houses should be in elevated place actually. Or suppose if we have occupied some lakes, rivers, and all, automatically the water will come into it. Okay, so that's the problem. Okay, so if we are constructing on the bank of the river, then we have to be see that what type of foundation we are using, whether we are using pile foundation. If at all any flood comes, okay, how we are going to manage. whether we have drainage, sewage pipes below the our house or below our roads, municipalities are working properly. So we are not worrying at all anything. Okay. So, but many cities in the world, if you see, most of the cities have located. Big cities are on the bank of the river. Okay, or a sea. You could see. Okay, the Thames River. London also is located. Okay, or maybe Chicago also you could see, and many cities you could see. Okay, Bangkok you also see. Okay, so likewise, but their understanding and the you could see at the foundation level the groundwork or the soil stabilization techniques they use is right. So there won't be any chances of flood and all in that case because they will be having proper drainage facilities. Once the rain comes, okay, or flood comes, automatically within hour everything goes okay. They'll collect the water, but it is not case in India, right? So whenever rain comes, you could see our roads. Okay, smaller few centimeter rains also stops everything. So we are not very much aware, and we are not very much rich also to spend a lot of money. So our priorities are different. Okay, we want to spend money on some other things, not in the basic needs actually. So we need to spend money on the basic needs, roads, infrastructure, footpaths. Okay, then we have to talk about the bullet trains and other things. Okay, that is also important and required. But thing is, when there is no footpath to walk, what you will do with the bullet train, right? So that's the thing. So we have to think in such a way that so that's the reason most of the cities in our river bank are polluted, and the foundation level or what we are providing is not sufficient. Okay, so likewise this permeability is the engineering property that because once we know the ease of water flow can flow through it, so we can plan it whether we will provide some drainage underground or some filters which will collect the water at the corner of the building. Okay, likewise there are so many techniques, or we will sometimes improve the soil. So when you do masters in geotechnical engineering, MTech, okay, like I have done it, PhDs, okay, like in Pile Foundation, I have done PhD. So our ground improvement techniques, there are so many ground improvement techniques by which we can improve the soil where we don't have opportunity to switch over the site. Suppose we want to construct a um, metro train, okay, and government decides that this particular metro train crosses this particular route, okay, but soil is not good there. In the what is the other option? We don't have any other option. We have to go for the construction. In that case, what kind of foundation we have to provide, and whether we need to improve the soil by using our ground improvement techniques. Okay, there are so many good companies in India. We have like L&T, Keller Groups, and BGR Energy, and many companies are working on that. Okay, so likewise, uh, we can improve the soil also. So it is the engineering properties, and this particular permeability we can measure from our laboratory and the field also we can measure it. Okay, so I think we have spent a lot of time while discussing. Anyway, now I'll explain this particular diagram to you. Okay, so how generally we find out this permeability? Let us take a small chamber here, A and B, and this is soil sample. Okay, so water is flowing from this to here. Okay, so we need to find out this permeability and all. Anyway, so now what we'll do is let us have point A. Oh, sorry, one, two, three. So we'll be having uh, heads. Okay, so water will try to flow along the soil and it will be collected here. Now when you insert a piezometer at any point, that particular water will rise. That is called the pressure head. Okay, so what we'll do is here This is one chamber, this is chamber, okay, this is water is moving from here to here, and these are the H1, okay, H2 and the H3 are the pressure heads, you can say, by using piezometer. H1, H2 and H3, when you insert here it will show the, so last, what is the loss of head here? So this is the A point, this is the B point, okay, this particular head is lost, that is called the hydraulic head. Okay, this is hydraulic head, that means compared to this one, or you can take this as the bottom, not bottom, datum. Okay, this is datum line, the dotted line is the datum line. Now this particular total head generally would be the elevation head, pressure head plus velocity head. You might have studied in uh, fluid mechanics, are going to study. Total head would be elevation head, that means where it is elevated exactly. Piezometer head or pressure head, once you insert a piezometer, whatever head you will get it, okay, that will calculate. Plus the velocity head. But what we'll do is velocity here, we will neglect it because soil flowing velocity would be very, very less, okay. So what we'll do is we'll neglect it. So here what we'll consider is elevation head, pressure head plus is equal to total head here. Okay. So we'll take a datum here. Okay, dotted line, and with that we'll measure the elevation. Okay, minus Z1 is the first A point, then minus Z2 is the second one, minus Z3 is the third one, okay, compared to the datum. And pressure head, you will get it H1 when you insert a piezometer, H2, H3 and all. And final head would be addition of the this one or subtraction of this one, okay. H1 minus Z1 will be H, H2 minus Z2 will be H dash, and this would be 0 here, okay. So finally what I am to try to say is, what is this head lost from here to, then only when we create head difference only the water will try to flow, right, by gravity. So if from upper head to down head the water will try to flow. If we keep it equal, then there may be very less chance of flowing the water, okay. So water will try to flow from the, because of the gravity, from higher head to lower head. And suppose H is the loss of the head, then how we can define this hydraulic gradient I? The loss of head per unit length of flow through the soil is equal to the hydraulic gradient, and it is represented by I. I is equal to loss of head divided by L. L is the length of the soil specimen. Suppose L is the length of specimen. Loss of head or whatever head you have next, this one, okay, head H. H divided by L will give the hydraulic gradient. Understand? So this hydraulic gradient, also HCl, we call it as the HCl, that is CD. Okay, from here. Now, this particular Darcy's law we will see. This is very, very important. They will ask in all competitive exams what is this Darcy's law all about. Okay, what Darcy's law says is velocity is directly proportional to hydraulic grade. V is, forget about K here. Okay, velocity is directly proportional to the hydraulic. It is whatever is says is correct only. Okay, if the hydraulic gradient is very high, okay, H by we have more head difference. Okay, H by L. Okay, if L is small, H is high, then what happens? Velocity will be high. Understand? So what is Darcy's law is all about? Velocity is directly proportional to the hydraulic gradient. Hydraulic gradient, then we can write it as V is equal to Ki. First, what we have to write is velocity is directly proportional to I, and we can write it V is equal to Ki. This particular K is nothing but the coefficient of the permeability. Understand? So this particular K is called the coefficient of the permeability. So V is directly proportional to the hydraulic gradient, or we can represent in the discharge term also. Okay, Q is equal to velocity into area, where velocity is equal to Ki. Understand? So we have seen velocity is called K. K is the coefficient of permeability, and the I is the hydraulic gradient, A is the area. So we can find out the discharge. That means once you know this discharge, okay, you can find out the permeability, okay, coefficient of permeability once you know the hydraulic gradient and from where the water is flowing through. This is all about the Darcy's law. Okay, velocity is directly proportional to the. This Darcy's law generally valid for laminar flow only. Okay, so you might have heard about the laminar flow. If not, also you will study in the fluid mechanics. Okay, that is out of our scope. Okay, we have three types: laminar flow, turbulent flow, transition flow, and so on. Okay, so which soil will be having more permeability here? Typical value, the it is given here in the tabular column. Clean gravel will be 10 to plus 1 to 2. Okay, at 10 to 100. Very good drainage property. Coarse grain medium sand 10 to 4 minus 2 mm per second. Okay, millimeter per seconds. Then fine loose silt, then dense silt, clay silt, and the silty clay. Silt and clay. Silty clay. Clay is more. Silty clay, not clay silt. Understand? Silty clay. Clay is predominant. Clay is more, but it is silty. Okay. One minute. Okay. So these are the things. Permeability very very poor. Okay, silty clay will have very poor permeability. Understand? So what is when the Darcy's law is valid? This is the valid for a laminar flow. Here, how we determine this coefficient of permeability uh, uh, for a soil? Okay, how we determine? So So how we can determine this permeability? Okay, permeability can be determined in the laboratory, can be determined in the field also. In the field, we determine the pumping out test, pumping in test. That means water would be pumped out, and we can measure the discharge. Once you know measure the discharge and area and all, we can measure in the laboratory also. We have constant head method and the variable head method. Two methods are very important. Okay, they'll ask in all the competitive gate exam and all. How you will find out the permeability in the laboratory. We have constant head method. One is variable head method. Constant head method we generally use for the coarse grain soil. Okay, and variable head method would be used for the fine grain soil. So we do have in our NIT these two tests whenever we do laboratory, geotechnical laboratory. Maybe I'll conduct, I'll take this permeability to show you. So what we'll do is, so this is all about the permeability, how you find out in the field and the laboratory. So, and we have seen the Darcy's law, which is velocity is directly proportional to hydraulic gradient. Hydraulic gradient is I equal to h by L. H is the loss of head. The more loss of the head or a difference in a head, by L. L is the length of this particular soil. That is gives the hydraulic gradient. Okay. So more is the so it again depends on the hydraulic gradient only this velocity. So that's what the Darcy's law is all about. Now what we'll do is I'll show video because once after teaching, if you see video, then your concept will be more clear. Okay, so that we can move on quickly. These videos are very good. Okay, that's the reason I'm showing you. Even I'm liking so much because they have explained very clearly. Okay, So because you can visualize very easily, visualize and you can think, and it clarifies all your doubt, okay, because it is in a 3D form, okay. So filing head method, constant head method, and the soil permeability Darcy's law. So what we'll do is, we will Darcy's law anyway. It is okay. Uh, anyway, first we'll see Darcy's law, then filing head and this one. Is it audible?
A soil mass is composed of small solid particles.
Is it audible?
Yes, sir.
Okay.
Which we call the soil grains. These soil grains, when depositing in a soil mass, arranges themselves in a way that some amount of empty space is left between them. We call these empty spaces voids. These voids or pores are interconnected and form a highly complex network of irregular tube-like structure. When water is subjected to a potential difference in the soil, it flows through these voids from high potential to low potential. The surface of the soil particles offers a resistance to the flow of water. The more irregular and narrower the voids, greater is the resistance posed to the water flowing. While more open the voids, greater is the ease with which water flows through the soil. This property of the soil, which permits the water or any liquid to flow through its voids, is called permeability. It is the ease with which water can flow through the soils. Gravel particles are large. Larger the soil grains, larger will be the volume of voids and better will be the connectivity of those pores. Consequently, large amount of water may flow through them easily and higher will be the flow of water. And that we say higher is the permeability of soil. A soil has different values of permeability for the different liquids, but we will focus only on soil's permeability with water. There is a huge difference in the permeability of different soils. These are the values of permeability of different soils. Gravel soils are most permeable, while clay soils are least. Clay soils have high void ratio, as they have a large volume of voids because of their flocculated structure. These voids look very large, but it is much zoomed view. And because the clay particles are being very small, these voids are poorly connected to each other and do not form a regular tube or channel-like structure. Hence, even after having large amount of voids, the clay soils are very less permeable. When a soil has extremely low permeability, it is termed as impervious soil. Water in the soil flows from one point to another only if there is a difference of hydraulic head. The hydraulic head is the amount of mechanical energy available at any point in the water. From Bernoulli's principle, the total head or total energy at a given point in the fluid is the energy due to the movement of the fluid, which we call velocity head, plus which is called pressure head, energy from the height of the fluid relative to any arbitrary datum, which is called elevation head. Datum can be understood as any reference line or plane. Here Z represents the height or elevation of the point of consideration from our considered datum. This total head has the unit of height, such as meters. When water flows through the soils, its velocity is very small. Therefore, we neglect the velocity head. Water flows from high energy region to lower energy region. If the hydraulic head of point A is higher than the head of B, water may flow from point A to B. Similarly, if head of B is higher than head of A, water may flow from point B to A. Water does not flow if the point A and B have the same energy or have inadequate head difference. Because even if A has higher elevation than point B, the hydraulic gradient of both the points is the same. Because hydraulic gradient, which is the sum of both elevation head and pressure head of both the points is same. Elevation of point A is higher than that of point B. But suppose if point B has high pressure head because of any geological confined aquifer conditions, then total head of point B may be higher than that of point A. In that case, water will flow from point B to A even against gravity. Note that fluid flows down from high hydraulic head to low hydraulic head. The change in the hydraulic head per unit distance over which this change occurs is called hydraulic gradient. It is written as this. Hydraulic gradient is determined by making several wells at some distances and measuring the water level in them. For example, to measure the hydraulic gradient of groundwater, we make two wells in the ground 1000 meters apart and measure the difference of water level in them. If the difference of water level in these two wells is 2 meter, the hydraulic gradient is 2 by 1000 or 0.002. We take a soil sample of length L and having a cross-sectional area of A. We subject it to some hydraulic gradient. We also measure the output discharge of the water through the soil. We can get the velocity of flow through the soil by continuity equation as velocity equal to the discharge divided by cross-sectional area of the soil. We increase the hydraulic gradient, and for different hydraulic gradient values, we note down corresponding velocity of water through the soil. We plot a graph between these obtained values of hydraulic gradient applied and velocity of flow. We will notice with the increase in the hydraulic gradient, velocity of flow also increases. We can divide this graph into three regions, namely Zone 1, Zone 2 and Zone 3. Zone 3, where the curve is irregular, displays the turbulent flow of water inside the voids. Zone 1 depicts the laminar flow and Zone 2 is transition zone. In laminar flow, the particles of water follow a defined path such that the path of one particle never intersects the path of any other particle, while turbulent flow is irregular. We can observe in Zone 1, hydraulic gradient and velocity of flow share a linear relationship. This relationship was first observed by French engineer Henry Darcy, and he proposed what is known as Darcy's law. He demonstrated, after doing experiments, that the velocity of flow of liquid between 2 points in the soil is directly proportional to the hydraulic gradient applied to it. We can write it as this by adding a proportionality constant K. K is the coefficient of permeability. V is the velocity of flow, which is also known as discharge velocity or superficial velocity. I is the hydraulic gradient. From this, we can write coefficient of permeability as this. Here, if the hydraulic gradient is unity, that is 1, the coefficient of permeability will be equal to the velocity of flow. In other words, the coefficient of permeability is the velocity of flow of liquid inside the soil if the hydraulic gradient is unity. The coefficient of permeability has the dimensions of velocity, as hydraulic gradient is dimensionless because it is length divided by length. Discharge through the soil can be written as cross-sectional area of the soil multiplied by velocity of flow. We can the velocity. Also the hydraulic gradient can be written as, so equation will become, the flow of liquid takes place actually through the soil pores, not through the whole cross-sectional area, because primarily this cross-sectional area is composed of soil solids and very less area is available for the voids. But for the calculations, we have considered the whole soil area. So let's say average area of the voids is AS and the flow of water in the soil pores as velocity Vs. Using the continuity equation, we can write discharge through whole cross-sectional area is actually equal to the discharge through its voids. we can rewrite it for pore velocity. Now let's apply some mathematics and powerful brainy techniques and multiply both numerator and denominator by the length of a specimen L. This is the total volume of soil sample and this is the total volume of voids. And if we write it as this, then we can see this ratio is the porosity of the soil. So we can write this equation as this velocity of liquid through void is called C. We know that porosity cannot be greater than 1. So if the quantity is 1, then this seepage velocity will always be greater than discharge velocity. To apply Darcy's law, we assume, that is, assumptions of Darcy's law, that soil is fully saturated, which means all the voids are completely filled with water. And second one is that the flow is laminar inside the voids. For large soil particles, gravel and higher hydraulic gradient, flow may become turbulent. For that, Darcy's law is invalid. Permeability is useful in many engineering problems, such as in an earth dam, we may need to estimate the quantity of water leakage through and under it. If a foundation is resting on a certain type of soil, and because of the overburden pressure, if water is escaping out of the soil, we may need to know how much time in which settlement will take place. That is, the rate of settlement of a foundation or building. To keep a toxic liquid in a lagoon, we must understand the permeability of soil, that how much liquid will pass through it, and how much time it will take to contaminate the water table below. Depending upon the work, sometimes we need to use the soils which restrict the flow of water, and sometimes we need to use soils which facilitate the flow of water, which are high permeability soils. Read Soil Permeability on elementaryengineeringlibrary.com. Link is in the description.
Hope it is clear, okay? So I have 11:30 class, okay, fine. Still we have time. So now let's focus on this constant head permeability. Is it visible?
Yes, sir.
Yes.
Audible? Yeah, please, what you do is you just go through this constant head permeability. Okay, so after this test, you can quit the meeting. Somebody called me for this some parcel. I'll be there. If I come, I'll be, continue. Otherwise, you can quit. Okay. So look at this one. I'll also be here only. Let us see.
Any soil, when depositing, contains some void in them.
You can quit the meeting
The
once it is
property.
over. Is it okay?
Yes, sir.
Okay, fine.
Of the soil which permits the water or any liquid to flow through it through voids is called permeability. Permeability is the ease with which water can flow through the soils. There are numerous methods through which we can measure the permeability of a soil in the field or of a representative sample in the laboratory.
Hello, sir.